Good afternoon. I'm María González Granados. I'm a PhD student at CSIC. And today I'm going to present a study we are carrying on, so it's still like a work in progress. Something I especially work in during my stay at the Polish Academy of Science with Carlos Bautista. It has a very long name, from first asked, first served to strategic prevention, special analysis for optimizing human-wildlife conflict prevention and compensation strategies. So human-wildlife interactions are getting more common and also more widespread in the territory, and these interactions may end into some type of conflicts, and this is especially the case with carnivore species because of the damage they can cause to people and also to their property. So human-wildlife conflict is one of the greatest threats to wildlife species, as some important organizations tell us. So it's very important that we approach conservation issues with this more holistic approach. So today I'm going to talk about human-bear conflict in southeast Poland, and it is especially focused with apiculture. Carlos Bautista and colleagues, they developed some years ago a special risk model in which they analyzed the risk of a beehive to be damaged by bear in an area in Poland, and they came out with this risk of damage map, which we think is very useful for management as a tool for also for prevention and for compensation system. And with this in mind, we wanted to know if this model was still useful with the new, because it was done some years ago and we had new data, we had new damages, and we wanted to check if this was still working. So it was like a good tool to use for management. So we have been working in southeast Poland, and here in this map you can see the orange dots corresponds to damages to apiaries. On south is a national park, so this is where the bear population is more dense. But because it's a national park and almost nobody lives there, we find less damages than in the buffer area of the national park. So with this in mind, we have different objectives, and the first one was to see if more severe damages are being located in high risk predicted areas, so if we could use this map as a tool, as I said before. The second objective was to know if preventive measures are being implemented effectively or not in high risk predicted areas. And third, what is the effect of prevention on cost of compensation? So a general idea of the damages so far. On the left, you can see for the whole period, so the one included in this previous study and also in this new one, that the number of damages occurring each year are increasing, and also that the typology are diverging a little bit, because in the previous year most of damages were caused to beehives, whereas in these last years we can find all the damages in poultry or more material goods, which could be related to expansion on the bear population, but also to bears coming closer to villages. On the right, you can see the temporal trend of damages, so it's also time on the axis, and this is probably due to the pulses in natural resources. So apparently, bear damages are related to the natural resources available, and because birds rely on mass species such as beech trees, it's important to take that into account for the management. So, and going to our first question, are more severe damages located in predicted high-risk areas? In this map, I plot the risk prediction in this previous model so that would be the grid in different colors. The higher or the more red, the higher the risk. And with the points, I wanted to take notice to the new damages. So the black points corresponds to the most costly damages, whereas the gray one to the least cost. So here we can have an idea, and it looks like new damages are more likely to occur in higher risk predicted areas. With this plot, what I wanted to emphasize was, again, these risk categories, which are each different bars in the plot. And then what I wanted to emphasize here was the amount compensated for each cell. So that means that's the meaning of the colors in green. So here it's interesting to notice that the higher the risk, the higher the amount compensated, but also, the higher the number of damages, of cells with damage, but also the higher the amount compensated, so we get more dark colors. Here is the same information, but now spatially. So again, blue and green colors means the amount compensated per cell. And here I also plot the individual damages, which I also split into more costly and less costly damages. So here it was the idea to get to know what is the nature of this cell, because it's not the same for a cell that was highly compensated to have several low damages comparing with this other one, circled in white, which was highly compensated, but just with one very intense damage. And this is important because in terms of the conflict we can get in these areas. So, and coming to our second question, if preventive measures are being implemented effectively, this is the same plot I showed you earlier with the temporal trend, but this time I also add the prevention system in green colors. So you can see here it started in the year 2015, but it still is not completely implemented, because if you look at the number of preventive measures installed, it's still very close to zero. So it's very likely that the preventive system is not going to work very effectively. But we have to test that. So, and this is how they are distributed in the field. You can see there are some of these preventive measures located in high-risk predicted areas, but also in others that are where the risk is not so high. So here we try to understand what was going on with this, and apparently, as far as we know, the system is first asked, first served. So no optimization is being made to distribute this preventive measure, which actually is quite a problematic thing, because economic resources are limited, and we should try to optimize this. So going through this third question, we wanted to know what is the effect of prevention on cost of compensations. So unfortunately, I'm not able to give an answer for that, because we are still working on with this, running the model, but the idea was to modelize costs, aggregate these costs for the cell, taking into account the prevention that was installed, damage persistent that is related with the occurrence of damages in a single cell during a period of time, also probability of wear, probability of damage, and also taking into account natural resources, because as I said earlier, it has a very important impact. And what was the problem or limitation with this data set? Well, one, it's a zero-inflated data set, because we don't have either compensation or prevention for every combination of cell and year. So we try to avoid to account for that with this random effect. Also, we have temporal, as I was saying, temporal autocorrelation, and with the spatial autocorrelation that we are aware of, we are trying to account for that with this probability of wear and probability of damage. Also, we don't know how long is the effect of an electric fence once it is installed in the field, because it should be cared and it needs some monitoring, so we are doing some scenarios for that. So as you see, it's a quite complex data set, and we are still trying to find a solution to model this. But so far we're trying with zero-inflated negative binomial models. And this is how our data set looks like right now. And just two simple ideas to take home. The first one would be that severe damages are more frequently located in high-risk predicted areas, so we could use this type of spatial risk analysis to guide the management. And the second one would be that the prevention system at the moment seems to be not effective in reducing the cost of compensations, probably because of the scarcity of it. Thank you very much.